Yes.
Okay. This is the gardener meeting. Today we have 3 topics on the agenda. First, Johannes will show the new gardener setup. So it's a new way to install gardener. Then Tim will talk about certificate service extension controller. And finally, Kristian will talk about exposing Kibana to end users. So Johannes, you can take over.
Actually, Andreas is gonna start.
Yeah,
right.
Also fine. The installer gang.
Can you guys hear me?
Yes.
Excellent. Wait, how do I share here? Share. Desktop. Okay. Go away. So, can you see our screen?
Yes.
Perfect. Okay, so today, Johannes, Uwe, and I, we wanted to present you our new garden installer. Before we begin, short agenda. So we have a couple of topics to cover today. So first, we're going to do an overview and a recap. Then we'll show you how to set up a gardener with our new tool called Saw. So then we have a short introduction into Saw. And maybe the most important part is actually the configuration of such a landscape. So we'll go step by step through what you have to do there. Then Johannes will be giving a live demo on how this looks and feels. And at the end, we will wrap up with status and what we are planning next. So recap, for those of you who didn't participate in our last presentation of the virtual gardener installer, so this is basically a raw schematics on what we are deploying into a Kubernetes cluster when we set up a gardener. So the first thing is we deploy a headless Kubernetes API server on top of an existing Kubernetes cluster. We deploy an ingress controller, and of course, the API server comes with its own etcd. And on top of that, we deploy it in the gardener components, like API server extension, controller manager, the dashboard, and identity. So how does this look in practice now using Saw? First, you need to install Saw. It's in our gardener GitHub organization. You just clone the repository. We have like 2 flavors on how to use Saw. One is a Dockerized one, which we will use here, which makes your life easier because every dependency is basically included inside the Docker image. You could also, of course, include that into your bash RC. Then we need to prepare and configure our garden landscape itself. For that, we just create an arbitrary directory where all the configuration files will land later on. Then in this directory, we clone this garden setup project, which actually describes how Saw should it basically install and what it should install into a given cluster. And this repository has to be cloned into a directory called crop. Then, of course, the configuration starts. We provide inside the garden setup an example YAML file, which you just copy into your root landscape directory. Then you open that file, edit it based on your infrastructure, put your credential in and whatnot. We will go into this part in a minute. And then you install Gardener by running Saw all or deploy all. And that's it. It's actually that easy. Of course not. And Uwe will now take over and give you a short intro in what is Saw and how to do the detailed configuration.
Yo, hi. To stick to the terminology of the garden environment, Saw is used to till the soil. So that's also the reason why the folder was called crop on the slide before. So it's a tiny tool that is based on a installation source that consists of multiple installation components, as shown here. So can be used to install whatever you want, as long as you have a set of such components that together form this installation source. Every component might offer a contract to be used by other components, and this results in an information flow between those components, and so does the orchestration and the dependency calculation and the deployment order of those components. So every installation components consumes the contract of used components, provides an own contract that will be then used by components that are later deployed. The installation steps itself are done by parameterized plugins. There are a couple of plugins coming with the SO installation, but you can extend the stuff by any plugin you want. The plugins we are using are a plugin for handling Helm deployments, Terraform deployments, direct manifest deployments using kube control, and then we have a Git plugin that is able to provide Git sources. That's the set of the plugins we are using. What SO does is it observes the dependencies, takes the contract information from the used components together with the central installation configuration, mangles this somehow, and the result will be a configuration file that describes the plugins that should be executed together with the configuration for the plugins that should be executed. And finally, the plugins are then executed in the right order, and the real work is done by the plugins that take their configuration and do whatever is described there to deploy the stuff to the target environment. So that's the basic way SO works. The Garden installer, as expected, provides such a set of components that is able to install the Garden environment. So I think now we have come to the configuration.
So basically this acre YAML, Johannes will show a concrete example later on in the demo. Consists of a couple of blocks which you have to fill out. So you start up by basically defining your landscape name, which you want to configure. Then we have like a general cluster information, like on which infrastructure you want to run, you're running, what's your domain, what's the kube config of this cluster, and at which region. Then you need to provide the network properties of your underlying cluster. So Gardener can exclude certain sitters from your shoot creation, so things don't collide there. Then there's a YAS part where you can define YAS specific configuration from which we derive an initial seed and the cloud profile for your setup. And of course, you have to provide here your cloud credentials based on the, if you're using GCP, you put a service account JSON in here, or your AWS credentials, and so on. The next part is the etcd part. So for etcd, we need a backup bucket where you can specify on which infrastructure this should be, also the region, and here also you can specify the credentials. So as you can see here, you can actually with the setup mix and match setups on, like, I don't know, running it on a GKE cluster, but using DNS record handling and a backup on Amazon, for example. We don't prohibit that. DNS, as I mentioned, is also configured in a similar way as the etcd backup part. You just define the type, which is kind of supported. type in your credentials. At the very end, we have the identity part, and that is basically to configure the Gardener dashboard and the DEX identity provider. So you can use basically static user configuration, or you can plug in any DEX supported connector for like doing OIDC authentication against GitHub or stuff like that. So it's again a link to the example, which is shown here. But I think without further ado, we will switch to the demo where Johannes can show you on a real system how this stuff looks like. Stop sharing.
Okay, can you hear me?
Yes.
Okay, so let me share my screen. Okay, so you should be able to see an empty terminal now. Just so you know where we are standing currently, I will show you what I already did. This is our README, our documentation for the garden setup project. So I already got myself a cluster. It's for this demo, it's a GKE cluster, but it doesn't really matter where it comes from. I also already downloaded Soul. I created a landscape folder, and I cloned the garden setup repository into it. And I also already did this part. Is basically if you get your kubeconfig for a GKE cluster, it doesn't come with basic auth credentials, but currently we need a kubeconfig with basic auth credentials. So we have this command which can convert it, and I also did that. So let's see. This is the folder we are currently in. It's the landscape folder. You can see here the acre YAML with the configuration and my kubeconfig. Crop is the garden setup project. You can ignore the other two files. Yeah, so this is kind of a demo acre YAML I filled in with dummy credentials, so you get an idea of how this looks when it's filled in. I have a landscape name. You can basically choose that one. And yeah, I chose also a domain. You can also choose that one. I put in the sitters of my cluster. It's a little bit tricky to find them out. And yeah, as you can see, I also used a kind of referencing here. So this creds, and this creds refers to this this creds node. So this service account JSON credentials will be inserted here and here. So uses the SPIF templating engine to do that. And yeah, also to show you that it's possible to use different providers for the infrastructure for like etcd backup and DNS. I didn't use Google Cloud DNS, but instead Amazon Route 53. Yeah, I used a local user, chosen email. This doesn't have to exist actually. And also here you can either give a clear text password, or you call it hash and then put a bcrypted hash in there. This is what I did. So yeah, my actual acre YAML looks like quite similar to this, but with valid credentials. First, let's have a look at the components So will deploy. Now you can see I use the imaged version of So I don't have to care for dependencies. And it will download the image since I don't have it locally. Okay, should be done any minute. Yeah. Yeah. So here now you can see all components that are defined in the garden setup project, and so ordered them according to their dependencies. For example, the gardener needs an ingress controller, so the ingress controller component will always be deployed before the gardener components, and so on. So this order is, yeah, it's automatically computed and should always work for your dependencies. We have also a help command for so, which will show you the commands you can do. It always takes a moment because it's every so command is executed inside a Docker container, and that needs to start. So we have standard so commands like the ones up here, and the additional commands like the convert kube config, for example, are defined in our garden setup project and not part of the original so. Yeah. So enough talking. Let's try it. I'll just deploy everything. Yeah, don't get confused by all the red lines. That's just my weird color scheme. Yes. Parallel, we can try to watch the garden namespace, which doesn't exist right now, but it will soon. Yeah, so now so we'll deploy all components one after another in the order we just saw. It's also possible to deploy a single component or to deploy all components that are not yet deployed. Yeah, using so we can also delete all the components again, which will use the inverted order. So the dependencies are removed in the correct order. So yeah, currently it's deploying an Nginx ingress controller.
Maybe while we wait, there were some questions in the chat. So first of all, you could, in theory, deploy this also on your on-prem cluster. And the thing is, you then need to define where etcd backup should be stored. So you could use, for instance, S3. And as for DNS, Route 53 or Google Cloud DNS. You can mix and match that. We're currently working on support for like designate OpenStack. We have this built in our DNS controller, but the configuration doesn't allow you that at the moment. And the second question I don't quite get. So the etcd backup is stored in a blob store, which you provide there. So we have a etcd backup sidecar, which is also part of our Gardener organization, and it basically does incremental snapshots into the bucket as defined in the configuration.
So persistent volume is not possible.
Yeah. Does this answer your question? For the private cloud case, of course, you have to make sure that you have to get your Kubernetes cluster from somewhere. We don't make any assumptions there where this comes from. So you could use Kubify for setting up stuff on OpenStack, or I don't know, you use kubeadm and then you set up something manually and then deploy Garden on top. This is also possible.
So yeah, as mentioned before, we have this so-called virtual setup. We basically deploy a Kube API server in the cluster as a workload. This is simply because there are lots of different ways how to get a Kubernetes cluster, and some of them, like for example GKE, don't offer the possibility to modify the Kube API server to set flags. But because we wanted to have this flexibility, we decided to deploy our own Kube API server. The only disadvantage that comes with this is that you basically have two kube configs, one for your original cluster where you have all the pods, and one for your virtual Kube API server. There are no pods running at all, but that's the API server that understands the Gardener resources, like shoots, for example. I will show you that when the setup is finished. So it should be done every second. Yes. So now we are done. Just before I show you the finished Gardener dashboard, when I show you the folder again, you will see that 3 new directories have appeared: export, gen, and state. Gen contains basically lots of temporary files that are created during the deployment. For example, if you download GitHub projects like we do for the Gardener itself, they are stored inside the gen folder. The export folder contains files that are produced by one component and needed by another component. So it's like the information flow between the components. And the state folder contains your state. So for example, the Terraform state for the etcd backup infrastructure, or credentials, or something like this. This means that the kube config for your virtual Kube API server is within the export folder. And it should be here. Yeah. So this kube config you can use to talk to your virtual API server that understands the Gardener resources. I can also show you that. So if I just do kubectl get shoots, it won't work because it's going against my base cluster, which doesn't know whatever a shoot is. We have also a shortcut built into so I can just do this. It's a little bit slow because it's run inside the image, but yeah, this kube config talked to our virtual cluster, and it knows what a shoot is, but there are just none. So as you can see, the dashboard prints out the URL it can be found on. If you ever lose that, you can also just type this and you will get it printed again. And let's see. Yeah, it's self-signed certificates, so just ignore this one. yeah, if you used GitHub to as an identity provider, then here would be some option to log into GitHub. But I used a local user, so I can just log in this way. So the project already created a project. It's called a garden project. It's called Core. It also already created a secret, added you as a member and an administrator. So you can just start and deploy your cluster if you want to. And there it is. Your first shoot is coming up. And I think that's it for the demo.
I have one wrap-up slide, and then maybe we can have Q&A afterwards if there are questions. Share my screen. So, can you see my slides?
Yes.
Okay, so currently we support Gardener 0.19, and I think 1.28 dashboard version. We have finished up basically all components for GCP and AWS support. What's currently missing, or partially missing, is are parts for Azure and OpenStack, but we will include this, I hope, in the next couple of weeks as well. So those 4 infrastructures should be supported for the setup. With that, of course, here the reference to the 2 projects. I'd say thank you. Yeah, try it out, please, and give us feedback if that setup works for you, or if there are any missing features, components which can be added.
Thank you.
I think that's all from our side.
Are there any questions? Okay, if that's not the case, then Tim can take over with certificate service extension controller. Tim?
Tim has some problems with his microphone.
Okay.
Hi, can you hear me?
Yes.
Okay, sorry for the delay.
No problem.
Technical issues. All right, so hi to everyone. Just let me share the presentation. Okay, so I hope this is also visible.
Yes.
Okay, great. Okay, so hi to everyone. Yeah, extension controllers. So you might have heard of our extensibility endeavors at Gardener, which is basically to extract some cloud-specific and deployment-specific logic out of the Gardener and put them inside some dedicated controllers. And one of them is a certificate service we offer via Gardener. And so the current, or the thing that I'm going to present, is to extract the whole certificate service logic into a separate controller called the extension certificate service. Okay, so maybe for a start, just look at the big picture I have on the slide here. So the left box is corresponding to a seed cluster, And basically, the most important thing is that we're going to have a extension controller here. This is the certificate service extension controller, which runs once in the seed. And in order to let it run, it needs configuration. It needs a cluster resource, which is nothing more than a resource which contains, for example, the shoot cluster and the seed cluster and the cloud profile. This is something that will be placed inside the seed from Gardener. And it also reconciles the extension resource. So whenever you have a resource of kind extension with the type certificate service, then this is reconciled by the extension controller, and which then triggers the installation of the certificate service in the seed. So, for example, when we place the certificate service controller inside the seed, it initially places or deploys a cert manager instance into the garden namespace or whatever namespace you configure the extension controller to install it in. In this example, it's the garden namespace, the cert manager, and most importantly, also the cluster issuer, which is responsible for issuing certificates for incoming requests. And whenever there's an extension resource coming in for this certificate service extension controller, then there's also going to be a cert broker instance per shoot namespace, which is then probably set up in this namespace. And which is also true for the shoot itself, because the cert broker needs certain RBAC manifests being placed inside the shoot. For example, it needs a cluster role and a cluster role binding to be able to list ingress objects, create secret objects, because it issues the certificates finally in the shoot cluster, and so on. So this is, the big picture of the whole system. Okay, so maybe we can look at the configuration first, at least a bit. So this would be the configuration which is passed to the certificate service extension controller. There you can, for example, modify some sync timings. In this example, that it is reconciling once an hour for the life cycle, and the service itself is reconciled in a 5-minute frequency. Then we give the cluster issuer, which is going to be created, a name. We need some namespace references. In this example, we need the namespace reference for the namespace in which the extension controller is running, as well as a namespace reference to, or we need define a namespace to which the cert broker, the cert manager will be installed. Then we have to define certain ACME parameters like the email and the server we want to use. In this example, we are using the staging service of Let's Encrypt. And we also have a provider section in which we need to define certain DNS providers which are able to resolve our DNS01 challenges. In this example, I have 2 Route 53 providers, one for the domain example.com and the other one for foo.bar. A second provider, or a second type of provider, which is also provided, is Google Cloud DNS. All right. Okay, so this is the basic configuration for the extension controller. And this is basically, the configuration is basically, or will be passed via Gardener to the seed and then set up correctly. Okay, let me show you how this would look like inside the seed cluster. And this is, I think, also important if you were a developer and wanted to test something with the certificate service extension controller, then you can follow these steps I'm going to show you. And you're also going to understand how the procedure works inside the seed cluster. So before we can start, we need some dependencies, of course. I prepared some of them. For example, we need certain namespaces. So I think these are certain or basic namespaces we anyways have in the seed. So we have the garden namespace. We have an example namespace for a shoot. And we also have a namespace called extension certificate service, which corresponds to a namespace in which the certificate service extension controller runs in. Second, we need the cluster resource. Okay, and what we basically need out of the cluster resource is the shoot domain of the cluster. Then we need the CA of the cluster. So whenever Gardener deploys a shoot cluster, there's also a CA bundle inside the shoot namespace in the seed cluster, and it has the CA certificate as well as the CA key. And with that in place, we can issue kube configs on a certificate basis for the shoot cluster. And this is also imperative to this extension controller. So we have that. And yeah, basically now we have the basic setup and we can start our controller. Of course, I do it here locally. I pass it the configuration I've just shown to you. And I do that as well with our make file. Okay, so it has been started, and the first thing, which was the first action the controller did, was to deploy the cert manager component. So when we have a look at the garden namespace, we have the cert manager instance running here. And we have also the second important part to issue certificates. We have the cluster issuer. You can have a look at it. So, and these are basically the values we passed in the configuration. Here we have, again, the two DNS01 providers, one for example.com, the other one for foo.bar, with all the credentials. And yeah, and we also have here the Let's Encrypt server that we are going to use. All right, so we have a cert manager in place, and the second scenario or the second step would be what happens if a shoot is created by a Gardener user. So that basically means for the certificate service that this extension resource I talked about is placed inside the cluster. So we can also have a look at this. It is also placed inside the shoot namespace in the seed. So this is nothing really special in terms of data management. It is more or less only that we have a extension with the type certificate service. And this triggers the certificate service extension controller to place the cert broker inside the shoot namespace. So when we have a look at the shoot namespace, here we can see the cert broker. We can also see that this cert broker instance was configured with the domain example.com and the provider example-com. So this is a match to what we have also configured for the cert manager, which is quite important here. All right, so now we have cert manager in place. We have cert broker in place for the shoot cluster we we kind of created, or we simulated it by the extension resource. And last but not least, let's go to the shoot cluster. And there we also have the cert program cluster role. As well as the cluster role binding, which is required for cert broker to operate correctly. Okay, let's maybe check. Do I have still the extension resource here? Yeah. It is all being succeeded, and yeah, it was all, everything was successful, worked fine. So I guess this is the overall picture of what the extension controller does for you to deploy the certificate service for Gardener. Any questions from your side?
Okay, if not, thank you very much. So in the meantime, Matthias has to leave the meeting, therefore I jump in. Was there a question?
I have a question about the certificate issuers. Is the vault in the support vault to set as the certificate issuer?
Sorry, what kind of support? Sorry, I didn't get it.
I mean, HashiCorp vault service.
No, what we support from Gardener, or
support for the certificate issuer. Because I know Search Manager has vault support for.
Okay. Yeah. Okay. At the moment, we only support Let's Encrypt. So this is what the setup is all about at the moment.
Okay.
So if you wanted to support Vault, you can also build it in, or you create a separate issuer for Vault. But this is possibly, yeah, this is something that's going to be accomplished. Yeah.
Okay.
So we basically take the vanilla cert manager from the community and just set it up for our own needs. When you need a second issuer or something like that, that's possible.
Mm-hmm.
Any other questions? Okay, then thank you very much, Tim. And we go to the last topic for today, and from Kristian, exposing Kibana to end users.
Okay. Can you hear me?
Yes.
Nice. So let's share my screen. So, okay. Okay, I'm ready.
Then we can see the screen. Go on.
So I'm going to talk about exposing Kibana to the end users, and with the end users, I mean non-administrator. First, the motivation. Currently, we keep the walks from the shoot clusters in the seed cluster in shoot namespaces, but non-administrator users cannot see them because they don't have access. And what we're going to see is how we will expose the Kibana to the non-administrator users. How we achieved it? We used SearchGuard plugin. This is open source plugin. Its code is in GitHub. And what can we do with this plugin is we can make different roles with different permissions to different Elasticsearch indices. And after that, we can just bind the users to its roles. So, okay, how did we achieve that? Let's suppose that we have users, the administrator or not, it doesn't matter. They moving in the same flow. Who wants to see its works? First, he have to access the ingress from Garden dashboard, for example, and he have to authenticate in front of the ingress. After that, the ingress will forward the authorization header to Kibana, and after that, Kibana makes call to Elasticsearch, where is the search guard, and there happens the authorization. So let's focus on this part of the chain, and let's zoom a little bit. Here we have search guard, Elasticsearch, and FluentD. First, we have the first thing we have to do is in FluentD to separate the logs in two parts. The part which we want to expose to the non-administrator users and another part. And for example, we will expose the logs from API server and control manager. And after that, in Elasticsearch, we will create two indices, the log/user and log/admin. And we will bind, we will forward the logs from API server and control manager to log/user and logs from another post to log/admin. And now we will create in search guard two roles, user and admin role. The user will have read-only access to the log/user index, and admin will have full access to both indices. And the last things we have to do is just to bind the users to their roles. So how, if you want, for example, to extend that logic and to give them logs for another pod, all we have to do is just to create another filter with 3 rows, and in the match, we just have to match the pod you want to expose. So that's easy, straightforward, and yeah, that's how we can expose another pod to the non-administrator users. And for more details, you can see the PRs. There are 3 PRs at the moment in the Gardener repo, in the Garden CTL, and in the dashboard. When we use the search guard plugin in Elasticsearch, all components which wants to talk with Elasticsearch have to authenticate in front of it. For that purpose, we have to adapt the Garden CTL with user, with which he will talk to the Elasticsearch and take the logs. And let's show it in a little demo to visit how to see how all the things works together. I'm going to show you the demo directly from the Garden dashboard. So here is my local shoot. First, I will show you that in my local Gardener cluster, I'm figuring now as administrator. That's my email. So
I think we don't see your.
Oops. Yeah.
Shell.
Yeah. Here we can see. So you can visit that you can see that I'm figuring as administrator in my local Garden cluster. So here is my cluster. And in the logging block, I have I can see the Kibana ingress, username and password. Let's copy the password, and login. So this. Okay, good. So let's click dashboard, podlogs, just to see that we can access all the pods. And we have full access with the admin user into the dashboard. Okay, so now let's change the things. I'm going to give wrong email, and I'm not figuring as administrator now in my Garden cluster. So when I refresh the dashboard, the username now, I can see again the login block, but the username now is user and the password is different too. So let's copy that. Let's open and see what will happen. Okay. Now I can see only logs from Kube API server and Kube control manager. And also I have only read permissions. I cannot do much things like, for example, get indices. I have no permissions for that, you can see. And that's the demo. We have now two users, one administrator and one not administrator. I worked as administrator and I had access on all of the pods, and now I'm worked as user and I can see only pods which are selected in the FluentD. And if you have any questions.
Okay, thank you very much. Seems that there are no questions. Then we are at the end. We have no other topics, and then we will close the meeting. Thank you for participating and see you next week, I think so. Oh no, in 2 weeks is the next community meeting. Bye.
Bye-bye.
Bye.
Bye-bye.